Hello, this is my DesignSpot Leak Killer Challenge solution. I'm going to give you a quick overview of the system subcomponents and then test it to demonstrate it working correctly. Over here we have our flow monitoring and control components. We have our Hall effect sensor, 12 volt regenerative dynamo, and a 12 volt solenoid valve and optional 12 volt electrical mains isolation relay. We also have this connected to a manual stopcock so we can demonstrate different types of flow. Over here we have our leak monitoring system components. We have our moisture sensors down the bottom. These are hooked up to CAN bus sensor cluster nodes. These send data over CAN bus to the main controller board seen here. These node errors are received by the MCP2515 CAN bus receiver board and send this data over SPI through the 3.3 to 5 volt conversion to our SciPy development board. This data can then be displayed on the LCD screen along with the flow speed from our Hall effect sensor. This data can then be timestamped with the real-time clock seen up here and then subsequently be saved to our SD card for later viewing by the user. And next we're going to test the main functions of the system. With power now going to the system, I can now demonstrate the functions that the system performs. With the LCD display on, we can now see the measured flow given by the Hall effect sensor, as well as the latest node error that has been triggered. We can also monitor these parameters on the Android app, as well as the solenoid and relay isolation status, seen here, and we can overwrite the isolation status manually using the app. So if I were to activate the isolator, you can see that the isolation LED has turned red, and the fact there is no water running, as you can hear. This status is also triggered by a maximum and time average non-zero minimum flow rate. We can demonstrate this by turning the water fully on to emulate a burst pipe. So I just deactivate the isolator using the app. You can hear it running. Put this fully on. And you can see that it's stopped itself because it's detected too much flow. The minimum threshold takes a lower average threshold over time to watch out for hairline cracks and taps that have been left on. The other isolation status is caused by error data from the moisture sensor clusters. The error data isolates the water and a unique error code is generated for use by the user on the LCD. So I can demonstrate this. Deactivate the isolator. Yes, therefore use the water from the tap. There you go. Now we can see that the LED has turned yellow to indicate that it's a node error and has isolated the system once again. All of the flow data and error codes from the nodes can be viewed later on the SD card at the user's convenience. And that's all. Thank you very much for watching.